This is lesson 2.6 of our Pre-Calc 11 class. Unit 2 is on polynomials. Lesson 6 is on a quadratic formula. In this lesson, we're going to learn what is a quadratic formula, how to solve a quadratic using the quadratic formula, and you can solve any quadratic with the quadratic formula. But there's reasons why you shouldn't sometimes. We'll get to that. And then how to determine if the roots or the solutions for a quad formula are real or imaginary. Okay, so as we learned, quadratic is a polynomial written in standard form where the biggest degree on the polynomial is x squared. So it could be in this form like this. It could be missing the bx, it could be missing the c, but it has to have the x squared. It can't have a fractional exponent, and it can't have an exponent larger than 2. Let's see here. If the quadratic function is in standard form, like such, 0 equals ax squared plus bx plus c, then the solution to x can be found using what we call the quadratic formula. But before I show you the formula, I want to make sure you're comfortable with the a, the b, and the c. The a and the b are just the coefficients on x squared and x respectively, and the c is just the constant term. So example A, it's y's instead of x's, but the 2 exponent is right here, so the a value would be 5. The y is right here, so the no exponent, or the exponent of 1. That means this is the b value, 13. And then our constant term, the plus 12, is right here, so that means c is 12. Take a moment, try these examples, make sure they all make sense to you. For example, B, A is 5, B is 13, C is 6. For example, C, A is 8, B is 18, and C is -5. And again, example B and C, you have to write in standard form. Example D is out of order, but A would be -7, B would be 5, and C would be 1. We're going to move on, but feel free to pause the video and make sure those make sense to you. Okay, so here's the quadratic formula. It could be written in 2 different ways. Because we have a plus or minus sign in the top, we can break it up as 2 fractions or write it as 1 whole fraction. So negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. This is the way I generally write it, and when we get to graphing quadratics, you'll see why. This is the other way you can write it, which is totally fine. This is probably more common. Negative b plus or minus the square root of b squared minus 4ac all over 2a. You might want to take a minute to notice the difference in the similarities between the 2 equations. We just basically make it 1 fraction since they have the same denominator, but all over 2a. Same thing. Okay, here's a better drawing for it. And if you are comfortable with the quad formula, you can turn this video off right now, because what we're going to do now is an activity. If you would like to do it again like we did in class, this is a great way to memorize the quadratic formula. What the procedure is going to be, I'm going to leave this up here. I would like you to write it down. So feel free to pause this video, go get a piece of paper and a pencil, or a marker and a whiteboard if you have that for some reason. You could do it on a window too. I don't know, if you've got rock countertops, you could probably do it on that. Just don't upset your parents by drawing on the countertops. Anyways, so the activity is this. Write everything down on the screen. The quadratic formula is x equals negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. For solving, 0 equals ax squared plus bx plus c. Write it all down. Pause the video if you need more time, because I'm going to move on. Once you've written it down, say it out loud. And then after that, erase your whiteboard or grab a new sheet of paper. Or better yet, take your paper, turn it upside down, and just write it on the back. That way, if you forget something, You can look at and cheat on the front. And I just gave you permission to do so, so I guess it's not really cheating, is it? Okay, try it again. Write everything down the way it was originally. Don't write the squares. Write things that were missing. I took 2 symbols away. And so I want you to pause the video if you haven't finished yet, so I can move on. Once you've done it, see how you did, see if you figure out what the missing pieces were. And then go ahead and say it to yourself again. The quadratic formula is x equals. Alright, on a new piece of paper, write it down again. And repeat the steps. You're going to want to pause the video because I'm going to go too fast for you to write. But repeat the steps. You got that first piece of paper with the quad formula written twice already, so you have a cheat sheet if you need it or if you want it. If you can do it without a cheat sheet, alright, try it again on a new piece of paper or the back side. If you could do it all without looking at your cheat sheet, you're in good shape. Alright, see how you did? New piece of paper, try it again. Alright, new piece of paper, try it again. New piece of paper, try it again. And reminder, if I'm going too fast, pause the video so you can keep up. I don't know anyone who could write as fast as I'm talking. That's crazy. Alright, new piece of paper, try it again. The quadratic formula is x equals negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. For solving, 0 equals ax squared plus bx plus c. Alright, hope that works for you. What I like about that activity is it kind of gives your brain a chance to see it and repeat it. If you're a verbal processor, you get a chance to say it. If you're a visual or kinesthetic, whatever, you get a chance to write it. Yeah. So a couple example problems. If we have a quadratic formula, we can use the quad formula to solve it. So in this case, we have a polynomial that's a quadratic. We can put it in standard form. We can identify, well, we could factor this thing if we know how. If we don't know how, or we just don't want to factor it, we can always use the quad formula. So in standard form, a is 8, b is 18, c is negative 5. So we can put negative b would be negative 18 over 2 times a, 2 times 8, plus or minus the square root of b squared, or 18 squared, minus 4ac, or 4 times 8 times negative 5, over 2a, or 2 times 8. We can simplify the front fraction, we can simplify the back fraction and the radical, and it's a lot of math. So this is the drawback to the quadratic formula, is sometimes if you can factor it, it's quicker and less work to factor than it is to use the quad formula. Unless it's really difficult to factor. Some box methods are really hard to do. Some quadratics are not going to be factorable. In either case, you can always use the quad formula. You just have to be careful with your calculations. So anyways, we get to negative 9 over 8 plus or minus 22 over 16, which means we could reduce that to negative 9 over 8 plus or minus 11 over 8. If we take the negative 9 plus 11 and write it over 8, we get 1/4, or 2 over 8, which is 1/4. If we take the negative 9 minus 11, we get negative 10, negative 20 over 8, which reduces to negative 5 over 2. So 1/4 and negative 5 over 2 are the answers. Okay, so if we factored this thing, it looks like we could have. Let's see, that would be 4x minus 1 and 2x plus 5 we simplified the fraction, so multiply the whole thing by 2, and that would be this factor. Fun fact. Okay, here's another one. We can write this equation in standard form. We can identify our A, B, and C, our 1, 10, and 4, respectively. And then we can set up the quad formula. And then we can simplify. In this case, we get down to an irrational number as part of our solution. So -5 plus or minus the square root of 21. You could leave your answer just like this, or you could write it out as two separate answers. -5 plus the square root of 21, or -5 minus the square root of 21. Either way of writing is totally fine. I picked the first one for me because it's less work. It's less writing. And so this is our final answer because we can't collect those like terms because they're not like terms. We have a square root and we have a numerical value. So that's it. Okay, this one is already in standard form, so we can just already apply the quad formula. A is 1, B is -6, C is 45. We set this up, and then we notice with our square root, we end up with a negative radicand. We have -144 inside of the square root. So that means, well, I know the square root of 144 is 12, but the square root of -1 is I. So if you ever have a negative inside the radical, that means we're going to have an I in our solution. So 12i over 2 is 6i, so 3 plus or minus 6i, and these are not like terms, so this is our final answer. Anytime you have a negative in here, you're going to get an I. One thing to note too is that if we use quadratic formula and we get what we call an imaginary solution or a complex solution, then what that means is that this original polynomial would not have been factorable. If we tried to factor this thing, couldn't do it. Now that I said that, you're going to try, aren't you? I bet you are. But you're not going to have any luck because it's not factorable. There, I said it again. For this problem, we'll have to use the quad formula. Okay, so let's talk about discriminants. The discriminant of a quadratic is the radicand of the quadratic formula. So that negative b minus 4ac, that whole bit inside the radical sign has a name, and that name is the discriminant. If the discriminant is if the discriminant is less than 0, as in it's a negative, then there are imaginary roots. As we learned in example C, the discriminant here is -144, and we have imaginary solutions. If the discriminant is greater than 0, as in it's positive, then there are two roots that aren't equal to each other. So like in this case, we have two roots and they're different. And in this case, we have two roots and they're different. And by roots, I mean solution. I'm using those words interchangeably. I'm sorry. Maybe it'll make more sense when we get to graphing. But when I say roots, I mean solutions. Let's see here. If the discriminant was 0, we'd be adding and subtracting nothing. Like if this said the square root is 0 instead of the square root of -144, we'd be 3 plus 0 and 3 minus 0. Well, that would just be 3 on both cases. So if the discriminant is 0, there is only one solution, or one root. And that is the negative b over 2a. So that's a good thing that I want you to know. Quick example, if the discriminant is 4, well that's greater than 0, so we have two real solutions that aren't equal. And they're rational because we can write them as a fraction. The square root of 4 is a perfect square. It's 2. So that's why it's rational. The last one, discriminant of 3. The square root of 3 is not rational, it's irrational. So that would be this one right here. They're real, they're unequal, but they're irrational because the square root of 3 is irrational. Discriminant, if it's 0, then we have real roots. They're rational because they're the same roots. If the discriminant is any negative number, we're going to have imaginary. You can't say, yeah, just imaginary. It's hard to say if they're rational or irrational because it's an imaginary number. We haven't imagined that part of the number yet, or have we? Anyways, here's an exercise that you're going to see in your homework, so I wanted to make sure you saw it right here. Alright, takeaways. We can use the quadratic formula to solve quadratic equations. The discriminant of the quad formula can help us understand what type of solutions we're going to find from the quad formula. And we know the quadratic formula. Yay.